Hello future EEs and CEs, this is Team Rotospin and Team Ironthine here to tell you a little bit about junior design and what we've learned from it, as well as to give you a sneak peek at our final project. The goal in the SwarmBot project was to construct a bot that will be able to identify toxic and non-toxic zones in an enclosed area. These areas are identified via a color change in the coarse area. A bot must work collectively with a partner bot to form a swarm bot that will efficiently search for these zones and communicate the status of the search with each other. This project, though a simplified version of a real-world application robotic system, simulates the process of building a fully functional bot with multiple subsystems. The idea of using SwarmBot technology to aid in critical problem solving, such as detecting and cleaning of hazardous waste materials, is very valuable to society because it reduces human risk in solving potentially harmful problems. Ooh, that had to hurt. Knowledge gained from courses over the last 3 years that were particularly useful in developing our bots included signal modulation and processing, C-based software programming, analog circuitry, and digital logic circuitry. Experience with the Arduino Mega 2560, including the accompanying software, was gained in this project. Throughout this project, we learned the importance of research, iteration in the development stage, communication with teammates, and organization as they apply to the engineering field. The bot project illustrates many of the skills you will develop as an electrical or computer engineer and gives a taste of what a project-oriented work environment will be like. C-based programming skills, hardware implementation, analog circuitry, and digital logic are all important skills you will develop. Simultaneously, you will develop communication, planning, and troubleshooting skills as they apply to engineering projects. We will now tell you a bit more about each subsystem that makes up our bot. The collision detection system is comprised of bumpers along the side of the bot. Each bumper is attached to a switch, and if one of the switches are pressed, the bot will react by turning in an appropriate direction to continue the search and prevent halting of movement.
Our bot uses an infrared LED and a phototransistor to detect color differences directly below the front. When the Arduino receives a value within a certain threshold, it stops the motors and begins to transmit to our companion bot. It also activates our Go Beyond circuit, which is a speaker connected to a 555 timer chip.
So the bot has now detected a non-toxic site and is now going to try and communicate with the other bot using a 25K signal via infrared LEDs and photodiodes.